jinkies. That was rough. Well, hello. It's been a couple of weeks, and I'm still Rob. I'm still that developer dad, as you can see. And I've been sicker than sick for like the past 2.5, 3 weeks or so. I got some nasty head and chest thing. It wasn't COVID, but woof. It was rough. I couldn't talk for more than a minute or so at a time without like getting into a nasty coughing fit. So I've taken the past couple of weeks off, and I'm back. I won't have an afternoon session because I do need to take one of the kids to a thing, but that's fine. I have not been idle, even though I haven't been streaming. Working towards getting this admin system together. I've kind of let myself fall down an ADHD rabbit hole and decided that I wanted to kind of more formalize this IFX project that you've seen in my other solutions and other projects, and I kind of want to turn it into a real actual thing. So let me bring up the stuff. Now I've got an extension to this thing in progress that I'm currently working on. So I'm going to continue working on that during this stream once we get started. So one of the things that really has always kind of just bugged me about .NET Core and Microsoft's dependency injection is the way that we set up the dependencies for the various components in our application. Now, if you're dealing with a flat sort of application structure or a very small web app, I'll load this up. Let's go to main screen focus. So let's say we're just dealing with a very small web app. And it's just like one thing. Edit text. Where's edit text? They keep moving stuff on me. Here we go. So we've got ASP, .NET Core. Let's say it's an MVC web app. It could be, or a web API. And we've got, give me a can. We've got a database. Some kind of DB. It could be SQL of some flavor. It could be whatever. It could be Mongo, Cosmos, Mariah, who cares? And then, of course, we've got maybe a third-party API out here in the cloud. And the way we've always done things is in program CS, we would, let's go home, and I want to push this stuff up to the top. Here we go. get rid of some of this white space. Now we might do inside here some components. Whoop. Let's change the shape fill on this to just green, whatever. And let's say we've got a controller, and we'll set the text fill to black on that guy. And our controller uses a DB context and it's got an HTTP client over here. And let's say we have another controller that does something else. But sometimes we need that something else to talk to the DB context, but it should never ever talk to the HTTP client. That's just for this guy. As a matter of fact, let's set those relationships up right now. And I'll shrink these guys down a bit. And let's add some arrows. So I'll go from you to you. And we need to adjust the outline. There we go. Connect this guy. And we'll connect that guy. And grab this arrow here. Now let's say this controller over here just deals with the HTTP client. And we've got our typical, let's throw something together and prove that we can do this type thing. No structure, no managers, engines, resource access, whatever. So what we have to do is we have to register this guy and this guy in the ambient dependency injection container. And then later on, let's say we need this controller to be able to save something over to our database. Well, all we would do in that case is we would add the DB context to this controller as a constructor dependency, and then the DI framework is going to take care of it. And we've just completely broken what little architecture we have because we've just broken single responsibility, so on and so forth. Because we've got a page out here that needs this controller, or that's already using this controller and needs to do things with both things instead of rethinking where we're placing the code. It allows for our inner or private dependencies to get polluted into places in our application where perhaps we don't necessarily want them. I'm just going to turn the music down a little bit because that's quite loud. All right. So that bugs me, and it really bugs me when we get into a more formalized manager A, manager B, and I'll come out to the front of this, and RA is for resource access. Is for resource access, and maybe we've got an engine or something like that in here. As a matter of fact, let's just go ahead and add one. Engine A. And so we instantiate these dependencies, and engine A is it's a highly volatile engine. It changes a lot, and it's really only intended to be consumed by manager A. But then someday we discover that we need manager B to get some functionality from engine A. And so we'll just inject that service into manager B, and we end up with this tightly coupled giant ball of mud with, tangled up barbed wire in the middle of the mud. Bad scene. I've always vastly preferred to be able to create subsystems and use those within my code. So let's just do one of these. And I'm going to change the fill on this guy so that it's a lighter blue. And I'm going to pull manager A. And my resource access. I'm going to send the subsystem to the back. I'm going to pull engine A over here. And we'll delete that. Let's say that manager A just deals with the DB context, and manager B deals with the HTTP client. And we've got this engine over here that's specific to this particular subsystem. And let's do this. Oh, come on. Here we go. And I need a little bit of text. Mr. Text Box, come here. No. Text box, subsystem A. And I'll just pop that text size down a little bit. We'll rotate it. And bring this bad boy up into here. Let's group all of these. Where's the range? Group. Floop. And we'll just pull this guy in here. Shrink him down just a scooch. Just a wee scooch. And then, of course, I'm not going to go to all the trouble of doing this with subsystem B, but you get the idea. Ideally, what I want to do is have these subsystems get configured as sort of a cohesive whole and then added to this guy's dependency injection. So what I've done is I've come up with the concept of a module or a service. I started off with module language and eventually turned it into service language. And so I created like a service provider and a service builder, and I'm able to drive everything from this architecture section that I've designed that lives in appsettings.json. And the story that I'm working on, or that I started working on Monday, and ran into some roadblocks because for some reason .NET Env doesn't work anymore. I'm doing this in .NET 9. Or I've forgotten some important detail or what have you about bringing .env files into the places where they need to go or what have you. But what I've got here is I've got these service options and some secret. I'm working on getting this to import from some external part of the configuration is what I'm doing. And I'm having trouble getting this part to load. I'll show you. So I've got local settings.env. That was a mutation that I tried to do. And I've got like iService, and I should probably make sure that's compliant with my manager. Yep, iService. I should probably change that to Service 1. Or rather, instead of that, SQL DB. Let's just pretend for the sake of that. So I need to take this key and replace this with that. But what we do here is I've got it broken up into, we'll talk about global behaviors in a little bit, but I've got it broken up into modules. And right now this test client, or the test console, has only one module. And it's just, I've got a logical name, I specify the contract, where to find the contract assembly, or which assembly the contract is declared in, whether it manifests as a singleton or scoped, how to find the implementation. Like this source says it's a module, and the assembly that holds the class to be built for the implementation class is this. Here's the options that I'm working on building out dynamically. We list the dependencies. And these dependencies, of course, are dictated by the implementation. And we've got our engine in here. The engine doesn't have any dependencies. And then we've got behaviors. We'll get into that. So what I've done is I've created this concept of a service provider where these modules, each of these modules gets loaded into this service provider construct. And then the service provider has a factory method that returns the actual service contract and implementation that's been built up in the service provider. And our service provider has its own DI container. And this is where we load in engine A, RA, stuff like that. And we can specify the settings, the connection strings, all of those things out here where we describe the dependencies. Once I've got that module settings thing figured out. And what that does is it prevents us from being able to accidentally leak our internal dependencies, so the sum engine here, up to the program level, where a well-meaning but poorly informed, or a well-meaning but pressured and in a hurry teammate might just grab that engine service and inject it into a subsystem that it doesn't belong in. And that's pretty cool. It lets us think about our applications in terms of these fully independent, reusable subsystems. Now, in addition to taking care of all the instantiation stuff, it also, when we request the service through this abstract acquire method, which I can probably make unabstract because it's basically the same no matter what. But I'll come down to the actual implementation of acquire on the generic service provider. And this is just generic service provider of type T. And I want to rename that symbol. Normally, I tend to stick with single character generic parameters, but T service contract. And let's type it correctly. There we go. So we've got a service provider of T service contract. It inherits from the non-generic service provider, where T service contract is a system component. We'll get in a system component in a minute. I use a lot of marker interfaces here, and a lot of people don't like those, and I'm on the fence, but it's a really, really great way of identifying which of my where my services get categorized within this closed architecture taxonomy system that I have learned to use. So we've got the generic service provider. Here's acquire. So what acquire does is we've got just a nullable object that represents the implementation. And I should probably rename that to concrete implementation. And then we log out that we're acquiring the service. If the lifetime is a singleton, we get my singleton, which is a private property on here. And if we are not a singleton, we just get the module service, which does some fancy footwork and so on. We'll dive into that in a second. And then we make sure that it's not null. We wrap it in what's called a pass-through proxy. I'll get to that in a second. It's just another layer of invisible abstraction that lets us wrap behaviors around the method calls from a consumer into our service. And that gets pretty handy. And then we just log out that we're serving the proxy for the contract name and return it. So we've got all of this extra goo happening in the midst of our call chains. And so here's get service from. What we do is we load the collection of constructors for the implementation type. And this type, the service type, let's rename that. There we go. And I've gotten into the habit, because I am using a larger font size, so I've got less horizontal real estate. I'm getting into the habit of moving my method parameters where each gets its own line. And yeah, I've seen people say vertical space is expensive. I disagree. I think horizontal space is far more expensive. So if there's no constructors on the service type, we just use the activator to create the instance. Otherwise, we get all the parameters from the for each constructor. We create a new object array that is the length of our parameters, and then all we do is rip through our service store, which is our module's internal private DI container, get the required service of that type. And of course, if we've got some generics in here or nullables, we have to get the first generic type argument. And then so on, we go activator.create instance with implementation type and args, and we're good. Although I suppose I could probably just invoke the constructor, which would be just as useful, because we've already got the constructor. I don't know. Copilot wrote some of this code for me. And then we return the result. So that gets us our actual class instance that implements the interface. And then back home in the acquire method, we wrap that in a proxy, and it's just a transparent pass-through proxy for now. There are other proxy types that I want to implement, but I've got to get this basic stuff working first. We add whatever behaviors have been configured for this particular module or dependency to the proxy, and then we return that proxy. Now, you might think that all of this goop, all of this proxying behavior and stuff like that ends up polluting our implementation code. And I am happy to say that even with all this stuff, even with all this enforcement, so here's the iService one. It's decorated as a manager service. iManager service inherits from iSystem component. iService is designated as a manager. There's no real functionality on manager or on iManager service or any of these taxonomy interfaces. They're just markers. So we've got void do something. And if we take a look at service one, this looks just like the way we would implement these services if we didn't have any of this proxying behavior. We're using standard .NET dependency injection here on the constructor. We're assigning these things up here. And then in here in do something, string the equation. This is just sort of like something that we use to print or log. We've got a numbers array, calc sum. That's just another interface and implementation. Here's engine one. Doesn't look terribly complicated or different from what you're used to. And we come into the implementation. It's just a C# class, man. Just a plain old C# class. No extra muss, no extra fuss. Do something. It does stuff. And all it does is like we write some stuff out to a console and log some stuff. That's it. And this is test code. Test code that I'm using while I develop the component settings story. Excuse me. And I can actually come out here to a terminal window. Where am I? And I can cd bin, cd debug, ls, cd net 9.0. Oh yeah, I'm using 9.0 here just because I want to kick its tires a little bit. And I believe I just go test console to run it. And we've got all of these log messages. So we've created our application logger. We had our utility services. The utility services are things like a generic logger, an untyped HTTP client. If I needed to, I could inject a DB context, but I feel like that's better handled at the actual, at the level of the service that uses the DB context. We had global logging to the shared services, and we just say that utility services are built, and then we start building out the application modules. So we build service one, we create a module provider for engine one, we say we have created the module provider for service one, our application modules are all registered, and then we acquire the service. And we can see that we're lazy creating that singleton service. Acquiring engine one, it acquires, created calc engine successfully. serving proxy for iEngine1, service1 created, and I might change a lot of these from info to trace messages. Created service successfully, blah, 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 serving proxy for iService1. And then we see these call timer behaviors. So we say entering do something with parameters system.object, entering calcsum with parameters.object. Now, you don't see, if I look at service1, I don't have any logging statements except for these test ones. In fact, let's go ahead and do this. We'll comment all of those out. No log statements. I'll rebuild. Come out here to the terminal again. I believe CLR. Nope. Clear. There we go. Test console. So lazy creating, entering call timer. There's that console.write line. And we see we've still got all these log messages. Without explicitly saying I want a log when my method execution starts, when it stops, and how long it takes. And that's because I'm using a behavior. Let's shrink all of these guys up, and we'll come back to my system framework. Now, I've defined a simple interface, iOperation behavior. We can set the behavior label. That's how I get the call timer for engine 1, call timer for service 1, whatever. And we've just got on method entry async, on method exit async, on method entry, and on method exit. And we've just got basically default behaviors on these. And then, of course, there's a method context, which has the name of the method, the parameters. I want to fix that up a little bit, the return value. And then if there's an exception, we've got an exception object here. I need to dig into that stuff a little bit more. But let's come down to call timer behavior. And all it does is it's just another basic, simple C# class. When we build the call timer, we just set up a logger because that's basically what the call timer does. We set our behavior label. Excuse me. And that replaces the default logger that the logger factory.create sets up here so that we can get some more information about what is being timed. And we just, before the call happens, we do this. After the call happens, we do that. And we get all of these delightful log messages, all of these call timers for free. Because we've wrapped the implementation classes for our system services in this pass-through proxy, injected the behaviors into the pass-through proxy, and then those behaviors execute so here's create proxy. Down here on invoke, where we override invoke, all we do is we create our method context. We run all of the injected on method entry behavior methods that are just sort of class wide. We want to run those for every single method. I've started adding the code to apply behaviors at the method level, but I haven't fully tested that yet. So we're not going to talk too much about that. We run the method with the instance of the service and our argument collection that got passed in on the invoke. We get the result. We await the task if it's a task. We set the return value. Otherwise, we just set the return value to that. If we have any method-specific post-call things, we run those here. We do all of the global behavior methods, and then we return our result. So right now I'm just using a call timer. I could inject an exception handler that would basically in here on, excuse me, method entry async, we could set up like, we could add some try-catch type stuff around it somehow. Actually, now that I'm thinking through it, an exception handling behavior might be a little bit trickier, or a lot trickier. I might have to do a specific kind of operation or a specific kind of behavior for that kind of thing. But whatever, doesn't matter. But yeah, so this gives us an awful lot of flexibility. An awful lot of flexibility. We can now inject unrelated to the use case technical functionality. And this is how we satisfy our technical requirements. We could devise a way to do internal load leveling. We could devise a way to use some .NET channels to create a internal to the application process pub sub mechanism that would allow us to have these components communicate over an AirSAT's message bus, for instance, without using something like Azure Service Bus or Rabbit or a full-fledged broker. We could give ourselves the ability to use that kind of interaction pattern inside our process. I haven't implemented that stuff yet. I may not. If I don't need it, I won't. So yeah, that is how we do this stuff. And that's what I've been working on. One more thing. I talk a lot about this closed architecture idea. And I believe it's implemented in Service Builder or Service Provider. Can't remember where. It might be in the type helpers. Oh, I believe it is actually in the type helper. So here's load implementing type from assembly. That's basically just a method that allows me to pass the name of a contract and the name of an assembly. And it looks at this assembly to find the first class that implements that contract and returns it. Class or structure. Get archetype. This is where we can define, this is where we figure out whether the contract that we're passing in is a client, manager, engine, resource access, or utility. This is where we get a list of which archetypes are allowed to hold which other archetypes as dependencies. And here's where we inspect whether we are adding a dependency or whether the dependency that we want to add is valid for the type of component we are adding it to. And this allows us to enforce the rules on our closed architecture. So if reference is not valid, we can actually throw an exception at build time that says resource access modules like iCharacter database may not depend on manager modules such as iCharacter Manager. So if we've configured a module out here that's a resource access module and try to inject a manager into it, it's going to crash on startup. And it's going to tell us why it crashed on startup. Additionally, I've got some rules on these modules that says modules that are declared as like top level within our architecture may be either client service. So like if we have a backend for front end API type thing, like I have over in the DM's familiar, I've got like this character workloads API that I stand up inside the Blazor app. That would fall under the client service or the iClient services archetype. We can also have managers. We cannot instantiate engines or resource access at the top level of our application process. In the extension method that I use to build out the to start building these modules, I actually validate the module archetype. So I pass in the specification for the module, which is just an object that's created from those configuration blocks. So I get the type for the module. I find its contract archetype, and I just get the name. So this whole thing just basically says manager service or manager client service engine resource access. And then we check if the reference is valid for iApplication container. An iApplication container is a special marker interface that we just use at the top level because that's what we're configuring, is an application container. And there we go. So we can actually play with this a little bit. I can show you. Let me grab the sum engine. All right. So we're going to grab this guy. This is all I need to instantiate a sum engine. And I'm just going to drop him in here, add a comma. Our JSON's valid. And we're trying to instantiate an engine at the top level of our application architecture. And if I try to run this, we're going to get that error. Let me come down here. There we go. I'll just pull this up here so that you can see. And I hit function F5, and off we go. And it's doing things. And this is where I'm working to try and get the environment stuff working. And it's being a struggle. And reference is not valid. Engine 1 is an iEngine service and cannot be added as a direct dependency. And we see module iEngine1 is not a valid archetype for the current dependency context. Cool. Well, let's carry on. And we should see, here's the unhandled exception and the stack trace. Fail program 0. Module iEngine1 is an iEngine service and cannot be added as a direct dependency of the application container. Beautiful. So let's close out of that. And where's my app settings? I'll get rid of this. Boop. Get rid of that extra blank line. There we go. Save. Run it again. And I can't find those, but that's fine. And I believe I should have a log warning in here somewhere. Lazy creating. Oh, that's right. The logger doesn't exist out here, but that's fine. It couldn't load that external setting. But I'll get that puzzled out offline. But yeah, that's the system framework. So we get all of these extra goodies. We get all of this architectural safety, and the impact on the code that we have to develop is minimal to none. And it's pretty damn sweet. I'm very, very happy with that. Yeah, we see a little bit of a performance hit on this. There's no reason. Do something should take 31 milliseconds, but 31 versus 20 isn't that high a cost. It really, really isn't. So I'm fine with it. There's more stuff that I want to do. I want to add a type cache so that as I do these assembly scans to resolve types, I only have to do that assembly scan once. Just little performance things like that, just to cut out repetition of or unnecessary repetition of work that could be considered expensive. But yeah, I'm quite happy with how this is working out, and my program CS has gotten exceptionally simple. We've just got this create app logger because I like to have a logger at my fingertips inside static void main so that I can log as things happen or error. I build out my configuration, I build the utilities, and as I say down in the, or as I've said in the documentation for this, this is where we add things like loggers, HTTP clients, untyped HTTP clients, et cetera, et cetera, et cetera. Here's where we configure the logging. We pull it out of the logging section of our config, all of that stuff. And this is build configuration. But our application services, we declare it as a new service collection. We call the add app architecture, passing the config, the utilities, and our basic logger. And then when we need it, we just materialize the service provider and pull our services from it as needed. Instead of having a long, long, long list of hard to read, hard to understand, risky to modify. Services.add transient, services.add scoped, services.add singleton, all of those things where we build out our dependency graph. Instead of having a very wide but shallow dependency graph, we've got a much narrower but deep nested dependency graph that allows us to actually materialize this isolated, self-contained, and cohesive subsystem structure that a good architecture wants us to use. And all of these ideas were taught to me by the good folks at iDesign. You can find them at iDesign.net. I am not affiliated with them. They don't pay me to say this, but I feel morally compelled to give credit where credit is due. The founder of iDesign wrote a book called Writing Software. If you are engaged in the act of making software happen, I 10 out of 10 recommend it. It is called Writing Software, RIGHTING, not WRIT. So, yeah, I got to bounce. Glad to be back in the saddle. I will be back tomorrow. This afternoon, I have to do human things and help one of my kids with something that he's working on. So I will be doing that, and I will be back tomorrow. Until then, take care of yourselves, and happy coding.